coming. You have the introduction of a theorem. If I asked you for, right now, could you define a postulate? If I give you a pop quiz, could you do it right now? Could you define a postulate? Oh, dagger, really? No one? Postulate is a rule that, it's like your mom says when you have to be home at 10 o'clock, what happens? You have to be home at 10 o'clock. Do you argue it? Hopefully not. A postulate is a rule that you accept to be true. You're not going to challenge it. Okay, now give me the true definition of a postulate. I like it. Almost perfect. Almost perfect. Definition of postulate. I should have done a pop quiz. Yeah?
Well, they accept it as true.
Yep. You just can't, if your mom says to come home at 10 o'clock, you have to come home at 10 o'clock, don't you? I hope you don't argue it. My boys do, but still, it's still a rule, right? Whatever we say, right? Okay, well, you're missing the whole point. Define postulate. A rule is a postulate if and only if. What are all definitions from this point forward? Have to be in what form? If and only if form. So a rule is a postulate, and then you can fill in exactly what you said. It's accepted to be true 100% of the time. So we have our first theorem. So a theorem is going to be a statement or a rule you have to prove true. Postulates, a statement or a conjecture or a rule that you do not prove true. Theorems, we need to prove them true. Now, to be honest, I don't probably prove every single theorem out there, but we're gonna try. We do a lot of them.
Say the definition again so that I can.
So what's the theorem definition? Who's got it? Yeah. You prove it to be true? Absolutely perfect. This is our first one, and it is theorem 2.1. The 2 stands for what chapter we're in, and the 1 stands for it's our first one in that chapter. Remember, just like the postulates and the numbers, their numbers, I don't even care what the numbers are. They're there just in case you want to go find them. You know to go to chapter 2, and you probably know to go to somewhat in the beginning of the chapter because it's the first one. It has a name, vertical angles theorem. Vertical angles theorem. And it simply says all vertical angles are congruent. Theorem 2.1, vertical angles theorem, says all vertical angles are congruent. So what do you need to know and memorize is all vertical angles are congruent. So we have to prove it. How do we prove it? We need to take something we know in chapter 1 and put it in there. Oh, I can use this. Okay, so let's look at this one, this picture, this diagram, and let's make that angle 60 degrees. So from chapter 1, you learned something named for that special couple, the 60 and the check mark. Do you remember what special couple name? They're supplementary, keep going. They're adjacent, so keep going. Third time's the charm. If they're adjacent and supplementary, If and only if they are a linear pair. That's the word. Okay, so linear pair. They are adjacent. Yes, they're supplementary because they make a line. So we can get the measure of this check marked angle because they know they have to add up to 180. So what's he going to be? What is that, 120? So he's going to be 120. Okay, so then we do it again. And we look at the linear pair going this way. The 120 and that check mark angle. What's the check mark going to be in this case? Because they're adjacent and they're supplementary. He's going to be what? 60. And you could do it again. It doesn't matter where I go. You could look there. 60 and what would that have to be? 120. And if you look, you have just proven all vertical angles are equal in measure. And for chapter 1, if they're equal in measure, they are congruent. Absolutely. So we sort of do a proof, not necessarily a 2-column proof, but just like a visual proof of why that works, and it worked beautifully.
And we just have to, like, if that was what we were having to prove, we could just draw the.
Yeah, you don't ever have to show me the proof.
Okay.
No, you're going to use this theorem now in other proofs because we proved it true. Good question. Okay, ready for the next one? Theorem 2-2, because they're in chapter 2 and it's our second one. Now don't copy the definition of it yet. Just copy the name. Congruent supplement theorem. And I came up with a story a long time ago, and then I used it again last year, and they seemed to like it. So I'm going to use it again this year, and you tell me if you like it or not. Okay, ready? I'm a senior at Marmion. Can you picture me? There I am at angle 1. And I'm going to go to homecoming. And Marmion changed their rule. And it says on the ticket, you and your date can only come to Marmion's homecoming if you're supplementary in weight. Meaning you have to add to what? 180. Okay, so I pick up Brooke. Okay, I am 100 pounds, so I pick up Brooke, and I'm so excited because she is 80 pounds, right? And can I go to Marmion's homecoming? Are we supplementary? Good? Okay, Brooke and I have a conversation, I say something stupid, and she dumps me the week before. Okay? I go, I pick up Faith. And I say, Faith, will you please go with me? Because I know that you are 80 pounds. And she goes, sure, right? And then what happens? I say something stupid, and what happens with Faith? She dumps me. I'm going to keep looking for people to take. And what do we know about all these people that I have to take? I have to first check to see if they're what? 80 pounds. So the theorem is a little weird. If 2, I want you to scrap the idea of 2. If all of these girls are supplementary to the same guy, if they're supplementary to the same guy, then what do we know about all these girls? They're all equal in measure, so they are all congruent. So if 2 or more, you could add, if 2 or more angles are supplementary to the same person or to the same angle, then they are going to be congruent to each other. If 2 angles are supplementary to the same angle, then the 2 angles have to be congruent. So, 2 years ago, Honors came up, they totally changed the name to Homecoming Ticket. They don't write congruent supplement theorem, they write Homecoming Ticket. And I let them use it in proofs, so feel free, it's no big deal. So if you ever see someone's notes or see someone talking about Homecoming Ticket, then absolutely, that's exactly what they're talking about. Okay, the next theorem is exactly the same, but the Marmion ticket changed. Instead of saying you and your date have to be supplementary, what do you think it's going to be? The complementary. So it is the congruent complement theorem is 2-3. So you and your date. Brooke, you gotta be really small, okay, on this one? If I'm 80 pounds, I go up to Brooke and I say, hey, how much do you weigh? She says 10 pounds. I go, yahoo! I can take you to Marmion's homecoming because the ticket says we have to be complimentary. And the same thing. Then she dumps me and Faith picks me up. She can only be 10 pounds because I'm staying the same. So if 2 or more angles are complementary to the same angle, then every single one of those dates are going to be the same measure or congruent. Again, call them homecoming ticket. I'm okay with it. And it doesn't matter if it's supplementary or complimentary. If 2 angles are complements of the same angle, then the angles are congruent. Okay? Fabuloso? Does it help with the ticket idea or no? A little bit? Maybe you'll remember it better? I don't know. We have 2 more to end it. Theorem 2.4 does not have a name. Don't you feel sort of bad for him? Just look. If angle 1 is a right angle, what is his angle measure? Okay, if angle 2 is a right angle, what is his angle measure? If you have all right angles, they all equal 90, they're all equal in measure, so the theorem 2.4 just says all right angles are that's it, all right angles are congruent. And you're like, sort of like a duh, but it is.
Could we name it?
Hmm?
Could we name it?
Yeah, what do you want to name it?
Right angle theorem. That's what I said. Yeah.
Right angle theorem. I think that name is used.
The congruent right angle theorem?
Yes, you could do congruent right angle theorem, I like it. I would give that to you in 2 seconds. I think the right angle theorem is used to say the measure of a right angle is 90 degrees. Okay. Theorem 2.5. Okay, stop and look really quick. I have 2 angles, how many? 2. They have 2 parts to them. They have to be the same. How many angles am I dealing with?
2.
And they have to be supplementary. So if I have 2 angles that are supplementary, they have to add to 180. Now, they have to be the same. They have to be congruent. So what kind of angle are these measures going to be? 90 and what?
90.
Right. So if 2 angles are both congruent and supplementary, then each of them has to be a right angle. That's all it says. If 2 angles are congruent and supplementary, then each of them has to be a right angle. And that ends our theorems for today. Your first few theorems ever. Aren't you excited? Okay, I have your homework. Are you ready? We're going to the book for section 2.6. One through 8. 16, 20, 33 through 35. 1 through 8, 16, 20, 33 through 35. 1 through 8, 16, 20, 33 through 35 in the book. Are you an iBook or a real book?
Real book. pictures of the.
You still don't have your book?
I think I have the hard cover.
Okay, so then just look for section 2.6.
Is it 16 and 17?
Yes. No. 16 only,
Oh, I was thinking
20, yeah. Okay, let me ask you, or can you pay attention for 30 seconds? The chapter starts off with identifying hypothesis and conclusions. Then it goes into writing converse, inverse, contrapositives, and biconditional statements. We quizzed on it. We're done with that. The next thing we did was the law of syllogism and the law of detachment. We did that. Then we go into algebra proofs and the properties. And then we did, for you guys, we did variable equations. Then we end with these few theorems. So tomorrow's review, oh, and truth tables for you. What do you want mostly reviewed tomorrow after we go through this homework? Variable equations?
Yeah.
What else?
Wait, was it the homework?
Yes. Variable equation proofs,
Yeah.
okay? Truth table maybe? Just a review of truth table? It would only be 2 variables on the test, not 3. So it'll be a shorter table.
Can we do the law of syllogism?
And we can practice law of syllogism, but you're okay with inverse, converse, contrapositive, identifying hypothesis, conclusion?
Can we do that?
Yeah, okay, so we gotta,
Just all of it?
I know, but we got 44 minutes to cram all that in there, does that make sense? Test on Monday. So, yeah, mostly variable equations.